Okay, now what you've all been waiting for, we're actually going to run the descriptive statistics. So first you can get summary statistics on the entire data set. One way you can do that is by just running summary and then tagging the data. This is a good way to make sure that all of the variables look like what you expect them to look like. So most of our variables we expect the minimum to be 1 and the maximum to be 5. You can see how many NAs are in each category. Left and right-handed, that looks about right with more right-handers than left. Groups are about equal there. There's more people with siblings than only children, so that looks good as well. Age, we have 15 through 30. That makes sense for a college-age population. Okay, this all looks good. Number of siblings, people had between 0 and 10 siblings with a mean of 1.2, which is about what you would expect, a little low on the mean. But it doesn't give you information on the standard deviations, and then also sometimes it doesn't give you the best information on these factor variables. So one of my favorite ways to get summary statistics on the data is with this skimmer package. You can do a skim of the data, and then it separates them out. So here's your factor variables and the different things that they can be and how many times it appears in the data. And then for all of your numeric variables, you have the number missing, the completion rate, mean, standard deviation, your percentiles, and it puts this cute little histogram here so you can just real quickly see the spread of the data and if it's normal or if it's skewed. You might also want to get summary statistics for just one variable instead of the entire data set. So then instead of putting in only the data set, you'll also do a $ and then tag the variable. So you can do this with skim, for example. You can also do it with summary, and it'll give you just the one variable that you call. You can also just ask for one summary statistic. So if you just want the mean of dance, for example, you can just ask for the mean of dance. But notice, if you do this and you just ask for the mean of dance, it's going to give you an NA. And that's because whenever you calculate a mean, you have to remove the NAs, otherwise it's going to give you an NA. So then you just add NA.remove equals true, and if you run it like that, then it will give you the mean. So if ever you have a problem running the means, then check to see if there's any NAs in your data and go ahead and remove those. Okay, so in R you can type out a question mark and then the function, and it will bring up a little help page down here in the corner that tells you about this function and how to use it. So you do skim and then you can tag the data in here. If you scroll all the way down to the bottom of these explanation pages, it usually gives you some examples. So this is if you definitely know the name of the package and you're searching for something specific. So like I know that there's a mean function and I want to know exactly how this mean function works. So there's one question mark and it brings up the mean function in base. But if you don't know what the function is and you just want to search more generally, so let's say we want to do standard deviation but we don't know what the function for standard deviation is, then we use 2 question marks. And this is going to do an internet search of the different R help pages. So we'll look through the different ways and packages that you can run standard deviation in. We don't want to download a new package, so we're just going to look for the one that's in the base version. It's this one right here, stats.sd, so I'll click on that. And I see that the function for this is actually SD. And then you just tag the data in it like you did for mean, and it has the same NA remove function. So using that, I now know that it is SD, and then I can tag my data. Are we doing music? dance. And then since we removed the NAs for the mean, we'll remove them for the standard deviation as well. When you type out true, it has to be, or false, it has to be in all capitals. Go ahead and run that. And then there's the standard deviation that goes with your mean. Okay, so for our t-test, we might want not just the summary statistics for all of the data, but we might want a summary statistic for male and a summary statistic for female, since we're comparing the two on a certain outcome. So in the psych package, you can use this describe by function, and it will give you two different outputs. This tells you the first one is female, and then the second one is male. And here is the mean for female, 3.93, the mean for male, 2.85. So it is a little bit less like we hypothesized, although we don't know if it's significantly different yet. We'll figure that out later. There's always a million different ways to do similar things in R, and that can get really confusing sometimes. So I just wanted to show you that there is a lot of different ways to do things like this. This is using the tidyverse code that you learned if you took the tidyverse series. So first you would want to remove the NAs from the group variable. And then we're going to group the data by gender. And then we're going to calculate the summary statistics. And this one's kind of cool because you can call whichever summary statistics you want. So here I'm calling the mean, the standard deviation, the minimum, the maximum, and the N of each of the groups. So the number of people in each of the groups. And then you get a little table that looks like this with female group and the male group. Again, female mean is a little bit higher, and they have a little bit more people. Okay, so now we're going to use one of these methods to get summary statistics by group for our t-test hypothesis. So our second t-test hypothesis was that only children will have more friends than people with siblings. So I'll do it this way first. Just copy this code. And we are doing data friends, and then the groups that we want to see if they're different or not is only child. We can go ahead and run that. And it gives us, with siblings, 3.33 is the mean, and 3.37 is the mean without siblings. So it doesn't look like our hypothesis is going to pan out there. They look awfully similar, but we will verify that in the coming workshops. Okay, I'll go ahead and do it the other way real quick as well, in case you want to use the tidyverse version. Okay, so maybe I'll change this to sibling data or sib data. And then the group that we want to remove the NAs from is going to be only child. And we want to group by only child. Okay. Oh, it didn't remove the NAs, but still there's our group means for both of those two different groups. And they're a little bit different because it didn't remove the NAs here. Okay. Now, I want to show you really quick that you can also group by more than one variable here. So, for instance, for our two-way ANOVA, we did gender and alcohol. And you can do that as well So this little exclamation mark means is not. So is not is NA. And then we'll do alcohol. Capitals and lowercase are always important in R, so those you want to match. Okay, let's run this again real quick. So if you group by two different things, then it will give you all of the groups separated out. So here's females who don't drink and they're mean. Here's females who drink socially and they're mean. Females who drink a lot and they're mean. And the same thing for males. So you can just add more group variables in there if you need to.